And I asked him for it, and he said it.
Like just that talking or like actual video?
Probably just a talking live stream. Probably just talking is my guess. But yeah, either way. So, because I don't want to drive up and then sit in the rain. So, all right, are we ready for our notes today?
Yeah.
Okay, pass in the blue papers. On Monday is the day you absolutely have to have your graphing calculator. So up until now, we've just kind of used them a little bit to help us with some graphing stuff. On Monday, you cannot do your homework without it. Okay? So you have to have it on Monday.
That's a packet?
It is a packet. It's not, this is not as bad. It's just because there's a lot of graphs on here, so I can't, they took up too much space. I know. It's really not that bad. Okay. So, example 1. We're just going to start off with an example. The graph shows the distance asteroid 2019 GC6 travels in X seconds. So that graph shows the time versus the distance. Write an equation of the line and interpret the slope. The asteroid came within 136,000 miles of Earth in April of 2019. About how long does it take the asteroid to travel that distance? Okay, so we got lots of things going on here. First thing it asks us to do is to do what? Write an equation. What do you guys need to write an equation? Slope. And in order to find the slope, you need 2 points. Now, yes, you could do rise over run on this, but be careful, the scales are not consistent, so you cannot count your blocks. Because the X scale is going by 1 and the Y scale is going by 4. So I typically don't count my blocks when I do this. I just grab 2 points off my graph. So there's 1 point that they gave us pretty distinctly right there, and it was the point 621. So I write that point down. What other point would be really easy to work with? Okay, go ahead.
0,
0, 0, right? So 0, 0. So now do what you did last night. Let's write an equation given these 2 points. Now, Caleb, what do we have to find first? Smudge right in front of my eyeball. Slope, right? Yeah. Okay, find the slope. How do you find the slope?
0 minus 21 over 0 minus 6.
0 minus 21 over 0 minus 6. What's 0 minus 21?
21.
Over what?
-6.
Now, let's reduce this fraction. A negative over a negative is a positive. And 3 will go into 21 how many times? 7 and into 6? 2. So I have my slope. Do I know my y-intercept without doing any work? Yeah. Where's it crossing the y-axis at? 0. So I also know B. Right here at 0. Remember, the definition of the y-intercept is where does it cross the y-axis? When x is 0. So right here, when x is 0, what's y? There's your y-intercept. All right, so with that in mind, I now have enough information. I have my slope, I have my y-intercept. So Caleb, the last question for you, what would this equation be in slope-intercept form?
Y equals 7 over 2x plus 0.
Okay, you can have the plus 0 if you want the plus 0, or you can just have y equals 7 over 2x. I don't care if you have the plus 0 or not. Okay, questions so far? Next thing it asks you to do is interpret the slope. Interpret the slope. That means, what did the slope mean? Okay, what did the slope mean? Well, remember, slope was rise over run, or change in y over change in x. This delta y over delta x, that means change in y. That's the Greek symbol delta. change in y over change in x. That's what that means. Okay, it's rise over run, or y2 minus y1 over x2 minus x1. Change in y over change in x. What did y represent? Okay, the distance in miles over the what? Time in seconds. Well, my slope was 7 over 2. Now, you wouldn't really give me that it went 7 miles every 2 seconds. If you're telling me how fast something is traveling, you're not going to say it goes 7 miles every 2 seconds. So let's go ahead and divide 7 by 2. What is 7 divided by 2? 3.5, 3.5. So that would be 3.5 what? Miles per second. So the asteroid is traveling 3.5 miles per second. That's what your slope means. The asteroid is traveling at a rate of 3.5 miles per second. Change in y over change in x. Look at your graph. Use the labels on your graph to help you with that. All right, now it says that the asteroid came within 136,000 miles from Earth. How long does it take it to travel that distance? Okay, do you guys remember the formula distance equals rate times time? You've used that in science before. Distance equals rate times time. You guys used that in science? Yeah. If I call Mr. Laubacher right now, he would tell me y'all learned it in honor science freshman year. Okay, distance equals rate times time. So what's my distance? 136,000. What is my rate? Remember, the rate is the same thing as your speed. What is the speed of my asteroid? 3.5 miles per second. And then time is t. So how do I solve this for t? Divide by what? 3.5. Now, when I divide by 3.5, what do I get for t? So I'm going to take my calculator. I'm going to do 136,000 divided by 3.5. And I get this ginormous number. What unit of time is this? Seconds, right? So it is 38,857.1 seconds. So if I'm worried about this asteroid hitting Earth, and I want to know as a citizen, how long is it going to take before it's going to blast into Earth? Does that information help me too much? So what should we change that to? Minutes. How would I change that to minutes? Or even maybe hours. Okay. Divide. Okay, so this again, going back to freshman science. I was just talking to Miss Franchezovic, who's teaching a freshman science this year. She's like, hey, your unit conversion. I'm like, and they've seen it a gazillion times. Okay, this is seconds. Since seconds are up here, you put seconds down here. How many seconds are in an hour? Do you guys know this? How many seconds are in a minute? How many minutes are in an hour? How many seconds are in an hour? Okay, so there's 3,600 seconds in 1 hour. My seconds cancel, so now you're going to do what? Well, God bless you. You multiply across the top, multiply across the bottom, and then divide. So you're just going to divide this number. Second entry, because I don't want to type that in again. And divide that by 3,600. And I get 10.8 hours. So our astronauts have 10.8 hours to knock this thing out of space before it comes down to Earth. Questions? All my people who want to be aerospace engineers. There you go. Questions? A little bit tricky. This time one at the bottom, I think the top half is easier. I think the bottom part, you got to work with that time a little bit. Distance equals rate times time. Any questions? All All right, next one. We have a car loan. We have the number of payments and your balance. What happens as you make more payments to how much you owe on your car? It goes down, right? Decreases. So it makes sense that this has negative slope. The graph shows the remaining balance, Y, on a car loan after making X payments. Write an equation. All right? Write an equation. Well, once again, I need how many points to write an equation? 2. What are the 2 points they gave you? Use the points they gave you. 0, 18, and 10, 15. Okay? Help me write my equation. Jack, what are you going to do first?
It's gonna be 15 minus 16.
18.
18.
Uh-huh.
And then 10 minus 0.
Good. What's 15 minus 18?
Negative 3.
Over
10.
10. Is that reduced? Yeah? Okay. What's your y-intercept, Jack? Do you know your y-intercept without doing any work?
18.
Yeah. Guys, your y-intercept, remember the y-intercept is wherever x is 0. So right here, x is 0. What's y? There's your y-intercept. Now, that doesn't mean if you take either one of those points, put it into your slope-intercept form or your point-slope form and do all the math, you'll get 18. This is way more work than you need. So, Jack, write the equation of the line.
Y equals negative 3 over 10 x plus 18.
Perfect. Okay. So he did the first part of this first part of A. It says, write the equation of a line. Interpret the slope and the y-intercept. This is the part you guys don't like. That means, what does the slope represent? Again, slope is change in y over change in x. Rise over run. y2 minus y1 over x2 minus x1. Change in y over change in x. What did y represent in my graph? Balance. Okay. That's the balance. So the amount of money over what was x? Number of what? Payments. Okay. Now, I have negative 3/10. Let's write that as a decimal. I have negative 0.3. Negative 0.3. Now we have to be careful. What does it say on the y about the money? That negative 0.3 is in what? Thousands. So let's multiply that by 1,000. And what do you get when you multiply negative 0.3 times 1,000? Negative 300. So my slope is really negative 300. Balance per payment. What does that mean about your payment? What does it mean? Okay, so your balance goes what? Down how much? $300 every time you make a payment. Balance goes down, decreases, however you want to say it, goes down $300 each payment. Okay, so there's my slope. Interpret the slope. Interpret the y-intercept. Again, my y-intercept is 18, but that's in what? Thousands. So what is my y-intercept actually? 18,000. Dot came in there when I wrote, sorry. 18,000. Now remember, this is the point 0, 18,000. X is the number of what? Y is the balance. So when you make 0 payments, you owe what? What does that mean? Huh? If I make 0 payments, that's when I what? I heard it. Bought the car, right? So when I bought the car, it cost what? Okay. When I bought the car for $18,000. That is ugly. All right. What do you guys think about that? Yeah. What is the remaining balance after you make 36 payments? Okay. What is the remaining balance? Well, payments, is that X or Y? X. So I'm going to go into my equation. And where I see X, I'm going to plug in what? 36. Do the math. Negative 3/10 or negative 0.3 times 36 plus 18. Now, I got to be careful because when I do that, I get negative 3/10. I just use division times 36 plus 18. You can do it all as one step. What is it? 7.2. Now, that's in what? So, multiply by 1,000. And what is your balance? How much do you owe after you've made 36 payments? $7,200. You still owe $7,200. What is the x-intercept and what is its meaning? What is the x-intercept and what is its meaning? So what's my x-intercept? If you look up here at the graph, where is it crossing the x-axis? 60. Okay, so that means 60, 0, right? That's the x-intercept. At 60, 0 is the x-intercept. What does that mean? Well, x is the number of what? Y is the, use words. So what's that mean? You're broke.
After 60 payments, you paid it off.
Okay. After 60 payments, you own the car, you've paid off the car, however you want to say it. Okay, so after 60 payments, you have paid off the car. Questions on that one? I know. Like I said, it's just a lot of thinking. All right, let's try another one. Two prom venues charge a rental fee plus a fee per student. So they say, okay, we're going to charge you this much money to be here, and then we're going to charge you for each student that you have. The more students you have, the more we're going to charge you. Okay? The table shows the cost for students at Lakeside Inn. So the table is Lakeside Inn. This is how much, if you have 100 students, it costs that much, 125, and so on. The total cost Y for X students at Sunset View is here. So that's Sunset. Which venue charges less per student, and for how many students would the cost be the same? What you have to do in a situation like this is write an equation for Lakeside. Write an equation for Lakeside. So, how many points do you need to write an equation? 2. How many did I give you? A whole bunch. Okay? Paige, which 2 points do you want to use for Lakeside? You pick.
100, and then 1,500, and then 125, and 1,300.
Okay, perfect. Help me write the equation. Those are the 2. You can use whatever 2 you wanted. Those are the 2 that Paige wanted to use. So what do we have to find first, Paige? How do you want to find the slope?
1,800 minus 1,500 over 125
So it's what?
300 over 25.
Which is what?
12.
12. Now, we got to find B. Do you like to use point slope or slope intercept?
Slope intercept. Alright, wait.
Paige's voice has gotten deeper.
Whatever the one's like y equals mx.
Okay, so which point do you want to use with your M?
The first one.
Okay, so when you go into y equals mx plus b, what are you plugging in for y?
1,000.
1500. How about m?
12.
X?
100.
Perfect. Okay. What's 12 times 100? 1200. And now what do you do, Paige?
Minus 1,100.
And what do you get?
300.
Okay. So what is the equation for Lakeside? What is the equation for Lakeside? Y equals 12x plus 300. Okay, so you do have to do that first, and I will ask you for that on the test or quiz. So now let's go to the first question. Which venue charges less per student? Well, remember, X is the number of students. How much does Lakeside charge per student? Does not charge 300 per student. Yeah, 300 would be the initial cost, and then they charge what? They charge 12 per student. Okay. How much does Sunview charge? Sunview charges 10 per student. Do you guys see? Because it's 10x. So who charges less per student? Sunview. So Sunview charges less per student. So now they're saying, okay, for how many students will they cost the same? How many students will the costs be the same? So what do you do to figure that one out? You take them and you set them what? Equal. So you just take Sunview, which was 10x plus 600, and you set it equal to Lakeside, which is 12x plus 300. And we solve this. So what am I going to do to solve this one, McKenna?
10x plus 600. Oh, you already did that. You have to subtract 300.
Okay, she's doing it differently than I would, but it still works. Subtract 300.
And then subtract
10x. And then what do you get?
300 equals 2x.
Okay.
And then you divide by 2 and then get x equals 150.
So what's that mean? It will cost the same for what? Cost the same for 150 students. That's kind of your point where you have to decide which one you want to use. Okay, how do we feel about that one? Okay, one more. Do you guys remember the line of best fit?
Oh, geez.
Oh, geez.
Sounds bad.
Sounds bad.
I remember it.
What's the line of best fit?
I remember.
Do you guys remember the line of best fit?
Yeah, I remember.
A little bit.
You failed it? All right. If I have a scatter plot, okay, the line of best fit is the line that goes through as many of the points of data as it can, where you have as many above as you do below. Okay, so it follows the trends of the data, and it minimizes the distance between the points on the top and the points on the bottom. That's how the book or the calculator calculates that. So, data do not always follow an exact linear relationship. So when the data in a scatter plot show an approximately linear relationship, we can model it with a line of best fit. Finding a line of best fit. Do not skip this one. If you come in and say, I don't remember how to do this, you better go to this key idea. Here's how you do it. Step one is make a scatter plot, like actually draw the scatter plot on a graph. That's step one. Step two, draw the line of best fit. You should have about as many points above the line as you do below the line. You don't have to have any points on the line. You probably will, but you don't have to. Choose 2 points that are on your line. They don't have to be data points. They might be. They don't have to be. They just have to be points that are on your line. And do what we've been doing to write the equation of that line. So, let's take a look at this. The table shows the length of your femur and your height. Now, obviously, the longer your femur, probably the what? Taller. There's probably a linear relationship in this. Okay? Do the data show a linear relationship? Well, let's put them on a graph and let's figure this out. It tells you it wants X to be the femur length. And this is in centimeters. And it wants Y to be the height. Also in centimeters. So first thing you're going to do is label your X and Y. It tells you which one is X and which one's Y. And now we have to figure out a scale. So as I look at my data, what is my smallest femur length? 30. What's my biggest femur length? 50. So if I go by like 5s or 10s, it's going to be really smushed. It's going to be really, really smushed. So here's what I'm going to do. I'm going to do what we call put a break in the graph. Have you ever heard or seen that? I'm going to put a break in the graph. It's not a great thing to do. You got to be careful. It will affect your y-intercept, so you cannot use the y-intercept because we broke the graph. And then I'm going to come over here and I'm going to say, okay, I'm going to let this be 30, and I'm going to go every other one at 5. So now I've kind of spread that graph out a little bit more. So technically my scale's by 2.5. Okay. How about the Y? What's my smallest Y value? 141. What's my biggest? 195. So I'm going to break it again. And I'm going to say, okay, I'm just going to start here, and I'm going to call this 100. And then I'm going to go every other one, 120, 140, 160, 180. So technically I am going by 10s, but I'm labeling every other. Is everybody okay with how I labeled my graph? Because that truly setting this up will be the hardest part of your homework tonight, the part you like the least. Because now it's easy. Now be careful. 40 is paired with 170, so you have to pair those together. So I'm going to go over to 40 and up to what? Put a dot. And then you're going to go over to 45 and up to 183. Put a dot. And then go ahead and I'll let you guys finish all of these. Oops. Please use graph paper on this one tonight. Okay, this is hard because I got a 45 183 and a 45 182 with a marker. It's not easy. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Always count. Make sure you have all your points when you're done. You should have 10.
Yep.
Now I'm going to draw my line of best fit. When I draw my line of best fit, I'm going to try to get as many points above as I do below. I'm going to have to move this a little bit down here. Oh. Now, your line will not be the exact same as mine. I did not extend it all the way to the y-axis because I broke that graph, and I don't want to think that that is a y-intercept because it's not. All right, so now at this point, is everybody at least to this point?
Yeah.
Draw, lightly draw, use a straight edge, draw your line of best fit. At this point, you want to pick 2 points that are on your line. Now, they do not have to be data set points, okay? They could be other points. They could be like if it crossed, see how, let me show you right here. If we wanted, we could use, this one looks like it crosses right on that grid. So I could, if I wanted to use this, it'd be 32.5, 150. Probably won't use that point, but I could if I wanted to, okay? You can use whatever points you want. I'm looking at my graph and I'm saying, it looks like it goes through that one pretty good, and it goes through that on my graph. Now your graph might be a little bit different. So on my graph, I'm going to use those 2 points. So I'm going to take, and I'm going to say, okay, my 2 points that I'm going to use is 40, what was 40? It was the point 40 what? 170. So I'm going to use 40, 170, and then I'm going to use the point 50 and 195. Yeah, I don't even know that I'm really going to finish this whole problem, because at this point, I would think you guys could you take these 2 points? Could you write an equation of, find the what? Slope. Use the slope, use one of the points, find the y-intercept. Write the equation of the line. Now, what you get and what I get could be different. After you write the equation of the line, it says use it. That means the equation, not the graph, to find the height of a person who has a femur that is 35 centimeters. So now what do you do with the 35? Plug it in for x. Plug it in for x and do the math. Do you guys feel okay with this?
Yeah.
Did you finish this okay? All right. Because I know that's long. So your homework tonight, you only have to graph numbers 11 and 12. You only have to graph numbers 11 and 12. You are doing 1 through 13 on. Graph numbers 11, I'm sorry, not 11 and 12, 11 and 13. 12 is not an odd number. Last time I checked. Man, I missed my Diet Coke at lunch today. I forgot it at home. It's Friday. I always treat myself to a Diet Coke on Friday. I had to go downstairs to the refrigerator and drink an expired Capri Sun. We have begged for a pop machine. You would think.
We got time to do it.